पे देख सकते हैं लैंडर मॉड्यूल।
People are applauding.
आदरणीय प्रधानमंत्री जी, sir, we have achieved soft landing on the moon. India is on the moon.
August 23, 2023, finally, India did it. India has become the first country landing on the south pole of the moon, and after USA, China and Russia, India has become the fourth country who has soft landed on the moon. And as soon as the rover came out of the lander, the Isro has received a picture which I will show you later. After watching this image, every Indian will be proud of his country because this the proof that India is finally on the moon. On October 22, 2008, the Chandrayaan-1 mission was launched by India. This spacecraft reached the moon and found something that was a headline all over the world: water on the moon. For the first time, Chandrayaan-1 brought strong evidence that there is water on the moon. Specifically speaking, it is present in the South Pole area of the moon. After this news, in countries all over the world, the craze to explore the moon renewed. Missions are sent regularly by the USA and China to the moon. Israel tried to do a soft landing on the moon. Besides this, many lunar missions were planned by Japan, Europe, and Russia. But today, the world is watching India's Chandrayaan-3 mission. Which new discovery will be made by Chandrayaan-3, and why did Chandrayaan-2 mission fail? Let's find out in this video.
India is on its way back to the moon.
The historic mission to the moon and the launch of India's Chandrayaan-3 spacecraft.
India is literally shooting for the moon.
Chandrayaan-3 mission aims to touch down on the moon's largely unexplored south pole.
Moon missions, the missions that are sent to the moon, can be of 5 to 6 different types. In the 1950s, humans started sending missions to the moon, and since then, as technology has improved, the complexity of these missions has also increased. The first and the simplest type of mission is a flyby mission. In this, a spacecraft is sent to the space, which passes by the moon. It doesn't orbit around the moon, but merely flies by the moon and leaves. The first successful flyby mission was launched by the Soviet Union in January 1959, when their spacecraft Lunar 1 passed by the moon. 2 months after this, America launched its first successful flyby mission, in March 1959, which was called Pioneer 4. Their aim was to study the moon from a distance. In October 1959, when the Soviet Union launched Luna 3, we got to see a close-up photo of the moon for the first time. You can see on the screen, this was the first photo of the other side of the moon, the dark side of the moon, which we normally never see from the Earth. Today, flyby missions are done only when the moon is on the way to some other mission, but if the moon is to be specially examined, then the next category of missions are deployed, the orbiter missions. In this, the spacecraft get close to the moon and orbit around the moon. This is called lunar orbit, and from there, they study moon's surface and atmosphere. Till date, more than 40 successful orbiter missions have been conducted, and this is still the most common type of moon mission. The first successful orbiter mission was once again conducted by the Soviet Union, Luna 10, in the year 1966. After this, comes the next category, impact missions. These missions are an extension of the orbiter missions. Here, the main spacecraft continues orbiting around the moon, but a part of the spacecraft gets detached and crash lands on the moon. Because it is impacting with the moon during the crash landing, these missions are called impact missions. You may ask, what is the use of crash landing? The answer is very simple. The time it takes to crash land, while it is getting closer to the moon's surface, many instrument readings can be taken at that time. That is why impact missions are also very useful. The Chandrayaan-1 was an impact mission. The part that is separated from the spacecraft and crash lands on the moon is called the Moon Impact Probe. The Moon Impact Probe of Chandrayaan-1 was equipped with an instrument called Chandra's Altitudinal Composition Explorer. In short, it was called CHASE. It was a mass spectrometer that kept taking readings every 4 seconds, while it was getting close to the surface for the crash land, and with the help of this instrument, we came to know that there is water in the atmosphere of the moon. This Moon Impact Probe crashed into the Shackleton crater. This crater on the moon was chosen, and the point of impact was named Jawahar Point. Chandrayaan 1 also had an orbiter which was carrying out its orbiter mission independently. Obviously, the Moon Impact Probe cannot be launched without an orbiter. NASA's instrument was installed in this orbiter, Moon Mineralogy Mapper M3. When the Moon Impact Probe crashed and landed on the Moon, some of the soil on the Moon's surface flew up. This instrument analyzed the lunar soil, and after this analysis, it was confirmed that there is water in Moon's soil. The fourth category of Moon missions is the lander missions. Here a part of the spacecraft is sent to the Moon for a soft landing, no crashing. It has to land softly, so that that part of the spacecraft can land on the Moon. The part that lands is usually called a lander. Doing this is insanely complicated, and when the US and the Soviet Union tried this for the first time, they failed in the first 15 attempts. 15 attempts is significant. In 1966, the first successful attempt was made by the Soviet Union, once again, in their Luna 9 mission. This was the world's first successful landing on the Moon, and this spacecraft also took the first photo of the Moon's surface. This photo looks something like this. Don't expect a very high-quality photo. This is from 1966. Usually, these landers are very bulky, they are very heavy and big, so they land on the Moon and stop there. They don't move around after that. If you want to move to the Moon, to solve this problem, there's the next category of Moon missions, the rover missions. Rovers are these small robots, which have wheels attached on them, so that they can move out of the lander and move around on the surface. With the help of rovers, direct contact can be established on the surface of the Moon. The first successful rover was sent to the Moon in November 1970, and can you guess which country it was? Once again, the Soviet Union. After this, the last category of Moon missions is human missions, where humans are put in landers and landed on the Moon, and instead of a rover, humans use their feet to step on Moon's surface. This was something that America did before the Soviet Union. In 1969, when Neil Armstrong first stepped on the Moon, NASA sent the last human Moon mission in 1972. Since then, no one has stepped on the Moon, and in total, only 12 people have set foot on the Moon. All of them were from NASA. You might be wondering, how was the first rover mission done after the first human mission? Why, this is because a soft landing was enough for a human mission, but for a rover mission, a new technology was needed to develop a rover. And this was done a year after Neil Armstrong's historic first steps on the Moon. The Chandrayaan 2 mission was planned as a rover mission. Had the mission gone as per plan, Vikram lander was set for a soft landing on the Moon, carrying inside a rover named Pragyan, which would have stepped out on the Moon. But unfortunately, this did not happen. On September 6, 2019, when Chandrayaan 2's Vikram lander was preparing for a soft landing, it suddenly crashed land. According to the Failure Committee report released in November 2019, this accident was caused by a software glitch. But Isro never made this report public. Isro was criticized for this as well because Isro was highly transparent till that point in time. It revealed everything to the public. For many months, Isro claimed that the lander was intact, hadn't broken, that it was merely lying tilted on the Moon's surface. But finally, when the pressure increased, on January 1, 2020, Isro's chief admitted that the lander had actually crashed and was destroyed. The screens at Isro's Mission Control Center showed that when Vikram lander was descending, it got off from its path when it was about 2 kilometers above the surface, and when it was about 335 meters above the surface, Isro lost contact, according to the plan. Till Vikram reached 400 meters above the surface, it had to lose almost all the velocity. But even at a height of 1 kilometer, Vikram's vertical velocity was 212 kilometers per hour and horizontal velocity was 173 kilometers per hour. Isro's current chief, S. Somanath, says that the problem was in Vikram's engine. Out of the 5 engines, one had a little more thrust, which made Vikram unstable. Actually, Vikram had to take photos to decide the actual landing spot, but it could never be stable enough to take photos. When it tried to correct its direction, it started spinning due to the misalignment of the thrusters. There was a limit on Vikram's software, on how fast it could spin. All these problems accumulated, and ultimately Vikram crash-landed because of these. That's all we know for now. Now if we talk about Chandrayaan 3, it was launched to fulfill the same objective that Chandrayaan 2 could not fulfill. To minimize the risk of mistakes, a lot of modifications have been made. First, the landing area has been enlarged. while Chandrayaan-2 had to land in a patch of 500 meter by 500 meter. This time Chandrayaan-3 can land anywhere in a 4 km by 2.4 km area. This is almost 40 times bigger than the last time. Secondly, Vikram lander in Chandrayaan-3 is carrying more fuel so that it can stay above the surface for a longer time and find the right landing site. Thirdly, there have been software upgrades so that Vikram can spin faster if needed. And fourthly, this time Vikram will not have to be dependent only on photos to land this time. The Chandrayaan-2 mission is considered to be half successful. Partially successful because the orbiter sent on Chandrayaan-2 is still working. In fact, it is orbiting the moon to this day. The high-resolution images taken by the Chandrayaan-2 orbiter have been fed to this new Vikram, so that the landing locations can be decided correctly, and the design of Vikram lander in Chandrayaan-3 is more or less the same as Chandrayaan-2, but a few modifications have been done, like the legs have been made stronger. More solar cells have been installed on it, and the sensors have been improved. Like Chandrayaan-2, the mission objective of Chandrayaan-3 is the same, landing on the south pole of the moon, and placing a rover. Now the landing site is 70 degrees south, with a large number of craters, that are always in the shade. Sunlight doesn't reach there, and that is why it is believed that in those craters, there could be traces of ice. Here, it is important to mention that, when the rover will be placed on the moon by Chandrayaan-3, it will get only 1 lunar day to conduct its scientific experiments. 1 lunar day is about 1 month on Earth. It is like 2 weeks of day and 2 weeks of night. So, the time to land on the moon was expected to be around 23rd and 24th of August, and the same happened, and from then, the rover has only 14 days to gather all the information, because the instruments present in Chandrayaan-3 are not made to withstand lunar nights. When it is night on the moon, the temperature drops a lot. The temperature can drop to minus 232 degrees Celsius. No instruments will work in this cold. That's why the Isro chief had said that they wanted the landing to be when the sun is rising on the moon. From then on, they would get 14 to 15 days to work. If it could not land around 23rd to 24th August, they would wait for another month, and land it in September. Coming to the instruments, Vikram lander weighs 1,750 kilograms, and the rover weighs 26 kilograms. The name of the rover is again Pragyan. In total, there are 3 modules in Chandrayaan-3, the lander module, the rover module, and the propulsion module. You know the purpose of the lander and the rover. The purpose of the propulsion module is to take Chandrayaan out of the Earth's orbit and send it towards the moon. With the help of this propulsion module, the lander and rover will first get into the moon's orbit, and when they reach the 100 km radius, they will be dropped for landing. There is no orbiter module in this mission because Chandrayaan-2's orbiter is still working and it will be used again. But the propulsion module will also keep circling the moon for 3 to 6 months. It will remain in moon's orbit. It will also be used for communication purposes and for taking other readings. An instrument is placed on this propulsion module, is spectropolarimetry of habitable planet Earth. Its short form is SHAPE. It will search for small exoplanets in space. If we talk about the instruments on the Vikram lander and Pragyan rover, they are very interesting. Pragyan has 2 instruments, LIBS and APXS. APXS stands for Alpha Particle X-ray Spectrometer. It will analyze the chemical composition of the moon's soil, which minerals are found in moon's soil, and second, LIBS stands for Laser-Induced Breakdown Spectroscope. It will do the same for the stones on the moon. When Pragyan landed, Isro received this very first photo, as I promised you to show you. Vikram lander has 4 instruments on it. The first is RUMBA. Its full form is Radio Anatomy of Moonbound Hypersensitive Ionosphere and Atmosphere. It will try to melt some small stones on the moon through a laser beam, and it will analyze the gas released from it. The second is CHASTE. The full form is Chandra's Surface Thermophysical Experiment. It will measure the thermal properties, the temperature at the south pole of the moon. The third is ILSA, the instrument for lunar seismic activity. It will measure the number of earthquakes on the moon. Those won't be called earthquakes, rather moonquakes. This will help us understand the crust and mantle structure of the moon. The fourth instrument is from NASA, the PLRA, Passive Laser Retroreflector Array. It will use laser to bounce signals from the Earth. With the help of this, scientists will be able to calculate the exact distance of where Vikram lander lands, and the range of the moon. because there are already 5 other such retroreflectors on the moon, so we will be able to find the exact distances on the moon. But apart from scientific experiments, there is the component of pride too. After this successful mission, India has become the 4th country after the Soviet Union, America and China to do a soft landing on the moon. It is a great victory for India.
People are applauding.
This was supposed to happen in 2019, if that part of the Chandrayaan-2 mission hadn't failed. Anyway, the Chandrayaan-1 impact mission made India the 5th country to touch the moon's surface, after the Soviet Union, America, Japan, and the European Space Agency, like Europe. Since then, 4 more countries have achieved this: China, Israel, Luxembourg, and the United Arab Emirates. These countries did this in 2009, 2019, March 2022, and December 2022 respectively. After Chandrayaan-3, the next big plan of Indian Space Agency is Gaganyaan, to develop a spacecraft which can take Indian astronauts into the orbit. Originally, this was planned for 2022, but there have been many delays in this mission. Now, it is expected to be done in 2025. If we talk about moon missions, Russia's Luna 25 was launched a few days ago, and the latest update is that it has crashed on the moon, so this Russian mission has failed. If you like the video, please subscribe, like and share the video and hit the bell icon for more videos. Thanks.